How you doing, guys? Welcome to another video. This is topic 1, volume 6, percentage compositions and empirical formula. Enjoy. Topic 1, volume 6, percentage compositions and empirical formulas. We look at how to calculate a percentage composition and we look at what is an empirical formula. The IB understandings are we need to know about empirical formulas and molecular formulas, and we need to know what they mean. We need to be able to convert between percentage compositions by mass and by percentage and work out the empirical formula. And then we need to be able to work out the molecular formula when we're given a molar mass and the empirical formula. We need to be able to apply those skills to different circumstances as well. Make sure you check out the text ref. Okay, so to calculate the percentage composition by mass of an element in a compound, all we need to do is get the molar mass of the element multiplied by how many of those atoms are in the compound and divide it by the total molar mass of a compound, multiply it by 100. So if we wanted to determine the percentage composition of all of the elements in potassium nitrate, then the first thing we need to do is work out the molar mass of potassium nitrate. So we need to know the mass of potassium plus the mass of nitrogen times 3 times the mass of oxygen, which gives us 101.11 grams per mole. And then to work out the percentage of potassium, we just get the mass of potassium, 39.1, divide it by the molar mass of potassium nitrate and multiply it by 100. That is the percentage composition of potassium. If we were to use the oxygen, well, we've got 3 oxygens in the formula, so we need to go 3 times 16 divided by the molar mass and multiply that by 100, giving us 47.47%. Now, to work out the mass of nitrogen, we could do the same procedure with the masses of nitrogen divided by the molar mass, or we could simply do 100 takeaway. Either of those will get you to the same result. So if we do the 100 take away the 2 percentages of potassium and oxygen, we work out the percentage of nitrogen to be 13.86%. So the definition of an empirical formula is one that you need to know. The empirical formula of a compound is the formula that gives the simplest whole ratio of elements in the compound. So for instance, H2O, that has a ratio of 2 hydrogens to 1 oxygen. For ethene in the middle, our ratio would be C2H4, but that's not the simplest ratio. If we divided both sides by 2, the simplest ratio would be 1 to 2. So we could write the formula as CH2. In the last one, because we've got a 3 in there, that's already the simplest ratio. So the empirical formula would be CHCl3. Now the steps to work out an empirical formula are the same whether or not we have a percentage or a mass. So in this example we have a percentage of carbon and a percentage of hydrogen. And what we need to do is divide those by percentages by the molar mass of the elements. So 75 divided by 12 for the carbon, 25 divided by 1.01 for the hydrogen gives us our values. To simplify our ratio, we need to divide the values by the smallest number, and then we're able to express it as the simplest ratio. So here we have 1 carbon to 4 hydrogens, so the empirical formula is CH4, and that chemical is methane. If we're asked to work out a molecular formula gives the actual number of different atoms covalently bonded in one molecule. It could be the same or it could be different to the empirical formula, but if it is different, it will simply be a multiple of the empirical formula. To work this out, we need to know the molar mass. So for example, a empirical formula that is the same as a molecular formula is water, H2O. In the second example, we have C2H6, which is ethane. Its empirical formula would actually be CH3. So the molecular formula is different to the empirical formula. So here we're given a chemical, we've told that we have 87.5% nitrogen, 12.5% hydrogen, and we're given its molar mass. The first thing we need to do is to determine the empirical formula. So we set up our ratio between nitrogen and hydrogen, We put in the percentages, we divide by the molar mass of the elements. That's going to give us a value, and once we get that value, we need to simplify the ratio by dividing by the smallest number. So in this case, we'll divide by 6.25 to simplify the ratio, which will leave us with a 1 to 2 ratio. So that means our empirical formula will be NH2. 1 nitrogen for every 2 hydrogens. Now the value is 1.98, but that's approximately a 1 to 2 ratio, so we could simply round that up. So our empirical formula is NH2. Now to work out our molecular formula, we need to use the molar mass. And what we will do here is try and work out the molar mass of the empirical formula. So the molar mass of the empirical formula would be nitrogen plus 2 hydrogens. And that's going to give us a value of 16.03. Now, because that molar mass is not the same as the molar mass of the chemical, then we know we need to multiply that by some factor. To work out what we need to multiply by, we can simply grab the molar mass of the chemical, divide it by the molar mass of our empirical formula, which gives us a value of 2. So that means we need to double our empirical formula to give us N2H4. The molecular formula will always be some whole number ratio of the empirical formula. So here's a worded example of an empirical formula. A 8.29 gram sample of a hydrocarbon, CXHY, was combusted or burnt in oxygen, and we were given 1.8 grams of water and 2.56 grams of carbon dioxide. So what we need to do for this one is we need to write a combustion equation. We have our hydrocarbon, we've burnt it in oxygen to produce 2.56 grams of carbon dioxide and 1.18 grams of water. So all of the carbon has gone into carbon dioxide and all of the hydrogen has gone into water. So what we need to do is we need to work out the number of moles of carbon dioxide and the number of moles of water. And then once we've worked those out, we need to work out just the number of moles of carbon and the number of moles of hydrogen, and then work out an empirical formula. So by doing mass over mole mass, I can work out the number of moles of carbon dioxide, 0.0582, and then using the same formula, I can work out the number of moles of water. Mass over molar mass. The mass of water was 1.18. The molar mass of water is 18.02, which gives me 0.0655 mole. Now what I need to do is set up my empirical formula, carbon to hydrogen. My number of moles of carbon, well, the number of moles of carbon and the number of moles of carbon dioxide are the same, 1 to 1. But with the water, the number of moles of hydrogen is double the number of moles of water. So I need to multiply the number of moles of water by 2. And I've done that in the formula. You could do it as a side calculation. Now we have to simplify the value by dividing by the smallest number, which gives us our ratio, which is 1 to 2.25. Now that's not a nice even number, 2.25. So what do you think we have to do here? We have to multiply it to get it to a whole number. Now multiplying this ratio by 4 will give us 2 whole numbers. We'll have 4 carbons and then 9 hydrogens. So that gives us an empirical formula of C4H9. Part B says another sample was analysed in a mass spectrometer. The mass spectrum produced showed that the molar mass of the compound was 114 grams per mole. What is its molecular formula? So to work out the molecular formula, the first thing we need to do is work out the molar mass of the empirical formula. And the molar mass of C4H9 is 57.13. That does not equal 114. So we've got to work out how many times do we have to multiply the the empirical formula by. So 114 divided by 57 is approximately equal to 2. That means we've got to multiply the empirical formula by 2 to work out the molecular formula. So we have 2 times C4H9, which would give us C8H18, which I know is a chemical called octane, and that is the formula, C8H18. Okay, the final example is a water of hydration practical type question. Now, a hydrated salt contains water molecules that are attached to it. So the formula of a hydrated salt, magnesium sulfate .XH2O, that means that we have a number of water molecules attached to the magnesium sulfate, and we say that it is hydrated. Now we can determine the hydration by driving off the water, and X is known as the degree of hydration. And what we need to do is use the data that we're given to determine that degree of hydration. So what we need to work out is how much water was lost from the salt. And then we also need to work out what the mass of the salt was at the end, because we've driven off the water, so we've got some water lost, and then we need to work out how much salt was left over. So to work out the mass of water, we do number 3 take away number 2, the amount after it was heated and the amount before we heated it. To work out the mass of the magnesium sulfate, we do 3 minus 1, the first amount that we added in. So to work out the mass of water driven off, 3 take away 2, that's 1.31 grams. To work out the mass of magnesium sulfate, 3 take away 1 is 1.25 grams. Once we've got the masses, we can now just simply set up an empirical formula. So we have 1.25 grams of magnesium sulfate. We divide that by the molar mass of magnesium sulfate. We've got the amount of water, which we divide by the molar mass of water. And then we're going to simplify the ratio to get the smaller, to work out the simplest whole ratio. So after working out the number of moles, we divide by the smallest number to work out the ratio. In this case, the 0.0104 is the smallest number. And that's going to allow us to determine the degree of hydration. So when we simplify that ratio, we get a 1 to 7 ratio. So our degree of hydration, we would say, is 7, because we've got 1 ionic salt crystal to 7 water molecules. So the formula for this hydrated salt would be MgSO4.7H2O. This is the lab that we'll do in class, so you'll be asked to do the weighings, heat the sample, and then to work out the degree of hydration. We use a little device called a crucible to help drive off the water, and we use a Bunsen burner on the blue flame to drive that water off as steam. So topic 1, volume 6, some top tips. We can either use the mass in grams or the percentage to calculate the empirical formula, and we need to practice the application type questions for this volume. There are lots of them. Thanks for watching, guys. Don't forget, drop a like on the video, subscribe if you're new, and I'll see you next time.